Hello, everyone. Thank you for joining us for the Arnold launch stream. I'm Jennifer Waters, Industry Marketing for Film and TV at Autodesk. And today I am joined by the Arnold product teams who are going to give you a look at the awesome new updates in the renderer. We will be recording the stream and it'll be posted on the YouTube shortly after the webinar is finished. Like some of you, many of us are working from home, and as much as we did troubleshoot for today's webinar, we ask that you please bear with us if there are any technical difficulties or connection issues. All right, let's run through the agenda. First up, Software Development Manager Frederic Servan will give you a quick introduction on what's new in Arnold. Next, Tiago East will walk through the new optimized denoisers. Then Adrian Haribel will give you a look at the latest improvements in Arnold GPU. Lastly, Pal Mazet will go over production-ready USD. We'll then wrap it up with a conclusion and a live Q&A at the end. Throughout the presentation, feel free to submit your questions in the Q&A panel at the bottom of the screen. We'll either save your questions for the live Q&A at the end or answer it right in the chat. All right, without further ado, I'll hand it off to Frederic.
Thank you, Jen. Let me share my screen. There we go. So hi, everyone. So my name is Frederic Servan. I'm the Software Development Manager for Arnold. I'm speaking to you from London. So let's display this statement. Everything we say, like we don't take any buying decision based on what we say. Okay, so I'm going to, we've just released Arnold 7 recently, and we're going to discuss a few of the features that were released in 7. And I would like to start by reintroducing images. I hope you're familiar with this new framework that we introduced in Arnold 6.0, I think. 6.1, thank you, Adrien. So this is a post-processing framework that's essentially a 2D operations that are interactive, that happen after the render, and that can operate on AOVs. And this is very useful to do, kind of classic image manipulations interactively when you render. So things like color correction or lens effects, or such 2D operations such as glow. Here's an example. Here's another one. Or bloom, I think is the name of the imager. So classic 2D operations. The cool thing about images is that they are part of the scene. So if you send them on the farm, well, first of all, it's saved in the scene, and it will run on the farm as well. Like another cool imager is the light mixer. So you can interactively balance your lights that are rendered in different AOVs, and you can render them interactively after rendering, so very, very quickly. Okay, so a new, because images are 2D operations, it's an extremely good fit for denoisers. And as you know, we were shipping already two denoisers with Arnold, and we've converted them to being images. So as you would do color correction, you can do also denoising and use any of the denoisers we provide. So previously we had the optics denoiser, which is an AI accelerated denoiser. So it's pretty fast, runs on GPU. And we had the Arnold denoiser that is called Noise, that is not AI accelerated, and that is slower, but is more suitable for, has production features such as like the sum of denoised AOVs equal to the beauty, and other features. Also, it has temporal stability, so you can feed it previous and next frames to denoise the current frame, and it will interpolate between those frames. So with Arnold 7, we introduced a new denoiser, which is the Intel one, Intel Open Image Denoise, or OIDEN is the acronym. So, which is kind of like a middle ground, and is a nice denoiser. I would advise to just try this one first if you're unsure which one to use, because it's AI accelerated. So it's pretty fast. It runs on CPU, so it runs everywhere, and the quality is really good. So yeah, you should definitely give it a go. I just want to show you the kind of results that you can get with the Intel Open Image Denoiser. On interior scenes, it's really good. And here's another example with a character, and you see noisy, and that's what you get. Okay, so this brief intro on the denoisers, with this intro on denoiser, I'll hand it over to Thiago to discuss in details the optimizations that were done for denoising and with OIDEN and other denoisers. Over to you, Thiago.
Thanks, Fred. Let me share my screen. All right, can you guys see this? I'll assume that's yes. So before we talk about denoising, I wanted to quickly show an optimization that went into Arnold 621 earlier this year. Partnering with Intel, we were able to optimize tune rendering and get it to scale to many cores. In this 64-core machine, we saw a 4x speedup. Now onto denoising in Arnold 7. First, let's see what IPR is like without any denoising and with denoising. Oh, sorry. This video should play for both people. Both. There you go. So in this case, we're using our new Intel Open Image Denoise. This scene is so noisy that without denoising, it's hard to even tell where we are. On the other hand, the Intel denoiser is always running during IPR, even at the initial blocky AA passes. And this lets us have a better idea of what we're looking at. Once we stop moving and let the image converge, we get a nice looking image in only a few seconds. This level of denoising interactivity required us to not only add the Intel denoiser, but also make numerous optimizations to imagers and IPR in general. Some notes on the Intel denoiser. You can find it by looking for the imager called Imager Denoiser OIDN. This denoiser is similar to the optics denoiser in how it works, except that it runs on the CPU, so everyone can use it. And as we saw before, it can run at the initial blocky passes. Like optics, this denoiser is not temporally stable, so you could get popping or flickering type artifacts if you use it to denoise overly noisy batch renders. If this is an issue, we recommend you continue to use the noise denoiser, which has production level features required for final frames. One of the improvements we added for the Intel denoiser also benefits optics denoising in Arnold 7. First, let's see where we were back with the Arnold 6.2 optics denoiser. Going from undenoised to denoised, we see a great improvement, except behind the piece of glass where the denoiser created a smeared result. Problem has to do with the albedo that we passed to the denoiser, not containing any specular info. The denoiser essentially sees an opaque piece of glass and has a hard time identifying what are features worth preserving and what is noise that should be blurred out. In Arnold 7, we created a new albedo AOV, which allows denoisers to see through certain specular reflections and refractions. This lets us denoise through glass. Let's look at Arnold 6 and 7 side by side. I think the less blurry denoising is clear. Another Arnold 7 improvement you might spot is that the textured area lights are now additive, so black parts of light textures are no longer shown. And this albedo improvement isn't limited to just seeing through glass. Specular reflections are also improved. Of course, this means shiny surfaces like metals will denoise better, but other materials that might also be immediately obvious as specular will also benefit. One great example shown here is hair, which can be mostly specular. In Arnold 6, the denoising albedo had essentially no information for the hair. Arnold 7 does. Let's see what the optics denoiser can do with this extra info. As you saw with the glass, when there's no information in the denoising albedo, we get blurred features. Same happened here with hair. Now Adrian will tell us about the GPU.
Hi, I'm Adrian. I'm a programmer on Arnold, and I'll be talking about GPU as Diego said. Thanks, Diego. So we continuously release new versions of Arnold, and we added new features to the GPU renderer in every update. Arnold GPU came a long way in the past few years, and we've been closing the gap and getting it closer to feature parity with CPU rendering. In addition to adding support for more and more features, we also worked a lot on fixing bugs and improving performance. And I'll go more in details in how we've improved performance in scalability in Arnold GPU. Oh, sorry. One thing that is very important in a production renderer is to be able to deal with large data sets, in particular textures. Thanks to our collaboration with NVIDIA, we introduced support for on-demand loading of sparse texture buffers in Arnold GPU. And this improved the memory usage a lot, as well as a metric we care about, which is the time to first pixel. As you don't need to preload all the potential data the renderer will need before displaying something on screen. And loading textures on demand also make it easy to implement production features such as UDIMs or texture tags and OSL textures. As with those features, it's quite complicated to know in advance which texture will end up being loaded in the scene. And as you can see on this graph, enabling sparse textures in Arnold 6.1 have a dramatic effect on the peak VRAM usage for Arnold GPU. And keep in mind that this is including the memory for the rest of the scene as well. So this really means that texture memory usage is an order of magnitude lower than when using sparse textures. And this means that it's possible to render large data sets on GPU using Arnold without massive amounts of VRAM. Another source of VRAM use is mesh data. And in Arnold 6.1 and Arnold 7, we halved the amount of VRAM used by meshes. And we did this by reusing most of the optimizations we use on Arnold CPU to compress mesh data. As you can see, CPU rendering is still using slightly less memory for meshes than GPU, but we hope to continue the trend and reduce memory consumption even more. So besides textures and meshes, another big source of VRAM usage is volume data. OpenVDB is the industry standard for representing volume data. It has a complex data structure, which is permitting live manipulation of the data, but not really practical for using as is on GPU. And when we added OpenVDB support to Arnold GPU, initially we converted the OpenVDB data structure to a denser grid, which works, but consumes large amount of VRAM. Now, Arnold GPU uses NanoVDB for OpenVDB volume rendering. And NanoVDB is a new addition to OpenVDB and was contributed by NVIDIA. It's a simplified representation of the OpenVDB data that is compatible with the core data structure, but compacted, linearized, and read-only. It really makes it efficient to traverse and query from GPU code. And in Arnold, this is completely replacing our previous 3D texture-based dense grid GPU backend. And the inclusion of NanoVDB in Arnold is another result of our collaboration with NVIDIA. So compared to our dense grid approach, our NanoVDB implementation reduces the memory usage for volume by a factor of 12, which is quite impressive. And this makes it suitable for rendering volume-heavy scenes on GPU. And due to the empty space keeping that is inherent in the data structure, our NanoVDB implementation is also faster to render than our dense grid approach. And you can see we even reduced the memory even more in Arnold 7. And this is because in Arnold 7, our NanoVDB now supports adaptive fixed point precision, which is a completely new thing that was introduced in NanoVDB and OpenVDB this year. And it brought a 50% reduction in GPU memory compared to Arnold 6.1. And all those releases happened this year. So you can see it's quite a steep curve for reducing memory and volume this year. So another game changer for GPU rendering performance is the introduction of the Ampere architecture, which was introduced, I think, 2 years ago now. So in Turing, only static triangles were benefiting from the hardware acceleration, as well as the BVH reversal. And you would typically see smaller gains when rendering a scene with motion blur meshes. And being able to render motion blur efficiently is super important for production rendering, as rendering with motion is also the default, generally the default when rendering the final frame. And on top of the improved ray tracing performance that you get with Ampere, we found out that it's also a lot better at dealing with the kind of large shader network that Arnold is used to render. A quick example is this scene. So this scene is an artificially heavy motion blur scene with a bunch of characters that are deformed with somewhat strong motion. And this is a very interesting scene because you can see between Pascal and Turing, like the GP100 and the RTX 6000, and there's a smaller performance gap than what you would typically see with other scenes. And that's how you see that the ray tracing hardware on Turing can't really accelerate motion blur. It's still faster than Turing because it's better than Pascal. It's still faster on Turing because Turing is better than Pascal at shaders and has more shader cores. But really, when you look at the result you get with Ampere, which has hardware support for motion blur, you can see how it brings more than a 2x speed compared to Turing. So this is for Ampere performance. It's really, we're really happy. Like Arnold was really optimized, and the Ampere architecture was really created with Arnold in mind. And you can see how it paid off. And this is again following our collaboration with NVIDIA. So improving time to first pixel interactivity when modifying the scene is really something that we are focusing on Arnold generally, not just Arnold GPU, Arnold in general, but even more so when rendering on GPU. Our efforts are really aiming for Arnold to be an interactive renderer, even when iterating on large scenes without compromising on features and quality. And the efforts we're making on Arnold GPU are paying off. Like more and more people are using Arnold GPU and talking about it and giving us feedback. As was shown as this kind of feedback we got on Arnold 7. So performance will likely continue to be an area of focus for Arnold GPU for quite some time. And we still have new features that need to be ported over, like the really hard ones, such as Student, for example, or Cryptomat. And really what we want to achieve now is be compatible with the CPU rendering and achieve feature parity. And now I'll go back to Fred, who wants to talk about USD.
Thank you, Adrien. So, yeah, but before I talk about USD, because you were really fast, I want to go back to this reaction. So we were really happy to see this. It was just days after Arnold 7 was released, and this is an interior render, really hard to render for Arnold because of the unidirectional path tracing technique that we're using. That has some advantages, but it's not the best for interior renders. And we see that the combination of fast GPU plus denoising makes this pretty interesting complex scene render in 2 minutes. So that's we're really happy to see this kind of feedback. Okay, so this bit is about our progress on USD and where we're at. It's a big focus of ours. Pal is one of the engineers working very actively on USD. Unfortunately, Pal is in Melbourne, so he's asleep at this time of the day. So he's recorded a small presentation, but I'm going to do some introduction on Arnold and USD. Right, so first of all, just to repeat, like something that we've repeated over and over, but just in case you didn't know, all our USD components for Arnold are open source, and we're developing it in an open source fashion. So it's not just the code that you see, but you see also all of our sprints, all of the bugs, everything that was tackled during a 2-week sprint. Where's our backlog at? And also what we prioritize in terms of feature requests and bug fixes. So it's all there. It's all there in the open, and like you're very welcome to participate, provide your feedback, and if you're bold or if you like it, you can also submit pull requests. So for new features or for fixes, we welcome that. Right. So in a few words, what do we have with Arnold USD in terms of components? So our goal is through USD extensions. I would say USD at large. So it's not just USD; it's also Hydra. But we're providing extensions to represent everything that Arnold can render or manipulate or take as input in USD and Hydra, so that you can have the benefits and the power of USD and apply this to anything that Arnold can render. So there's many ways to consume USD with Arnold. So the first thing is that USD is a scene file format for Arnold. So like AS files. So you can save an Arnold scene as an AS file, as you know, as an archive of the render scene, but you can save it as a USD file as well, and it will contain all the information that you would have in an AS file, and thus you can render directly USD files. Another very easy way to consume USD in Arnold is to use the USD procedural. So in this case, USD is yet another file format that Arnold can ingest. Okay, so like Alembic or like an AS file. And this is, and the UI in Maya in this case is exactly the same. So, but instead of having like an ABC file here, or you have a USD file, you can also view the contents of the USD file. You can apply overrides, apply shaders, set up operators on it using this UI. So it's really yet another procedural. Okay, so that's very easy to consume USD data. Now, with Hydra, also we are providing a render delegate. So a render delegate, a Hydra render delegate, is a way to render interactively a USD stage and reflect the changes in the scene back to the renderer in an interactive fashion. So that makes it very easy to integrate any renderer, and Arnold in this case, in any application that supports the Hydra framework. Okay, one such application is Maya. So with the Maya USD plugin, where you can render through a USD stage represented in Maya in Arnold's Hydra delegate. With Maya USD, we support also Bifrost and Bifrost USD extensions with Arnold. All this is happily sharing information and working together. Just a few highlights on like what we support for Maya USD, like recent additions. So we now can export directly from Maya the USD scene, but containing all the Arnold shaders through the Maya export. We're also sharing a stage, like the USD stage, between Maya and the Maya proxy in the Maya scene and the Arnold procedural. So any edits you do in Maya to the USD stage will interactively update in Arnold. And as I said, also we support the Bifrost USD extension. Another application that is deeply involved with USD is Houdini and Houdini Solaris in particular. So the lob context in Houdini. So this is something that we've supported from the beginning, from the release of the initial release of Houdini Solaris, and we continue to do this. It's challenging. There's lots of things. There's lots of parts that are moving in Solaris, in Hydra, in USD, and in Arnold. So, but we're spending a lot of effort in this area, and is getting lots of support requests. Okay, so now I'm going to play Pal's video, which is entirely in Houdini Solaris, and he's going to showcase the things that were recently implemented in Solaris and how you can create and manipulate scenes, a Solaris scene in Houdini.
Hey, my name is Pal Mazzi, and I'm one of the developers working on our USD integration and tools. Today, I'm going to talk about two of the new Solaris.
Can you hear anything?
You have to share the audio when you share the desktop. When you click on the share button, you have to click on share the audio.
Okay, so share screen or share sound. Yes, optimize for video. Yeah, we were told this before, but I forgot. So, go. And again.
Hey, my name is Pal Mazzi, and I'm one of the developers working on our USD integration and tools. Today I'm going to talk about two of the new Solaris features we included in our latest release, Arnold 7 and Houdini to Arnold 6, deep rendering and render time procedurals. But first, I'm going to put together a small test scene to work with. Let's start with render time procedurals. The new release ships with a collection of Arnold USD schemas, small building blocks to describe Arnold-specific primitives in a USD context. These blocks allow you to have Arnold primitives in your stage, otherwise not present in USD. Think of Arnold procedurals, shapes, and lights. For now, we focused on supporting the render time procedurals, ASS, USD, and Alembic in Solaris. Why it is important? At the moment, USD and Hydra are still a quickly moving target. Lots of Arnold native concepts are hard to express, and we are limited to workarounds that can break easily. For example, mesh lights don't work well in Solaris. Mesh lights are missing from the light loop, and Hydra cannot track the relationship and the updates between the light and the mesh. By using render time procedurals, it's possible to work around these limitations and import Arnold scenes directly. I prepared a simple ASS file that contains a mesh light using a torus, so let's import it in our scene. First, I'm using the primitive lob to put my Arnold procedural schema in the scene. Then using the edit properties lob, I can change the primitive's parameters. Houdini lists all the parameters available for our schema, so I can drag and drop them to the edit properties lob interface. For now, I'm only using the file name parameter to point the procedural to my ASS file. Since the Arnold procedural inherits from standard USD-GM schemas, I can use the transform lob to apply transformations. Now there you go, the mesh light is visible in the scene. Once I merge the procedural with the rest of the scene, we can see that everything renders together as expected. I can do the same using an Alembic file. The Arnold Alembic USD schema renders Alembic files directly. I can also set the frame parameter to import animation with correct motion blur. One of the advantages of choosing Arnold Alembic over referencing Alembic files in USD is that the Alembic data is only read during renders. Your USD stage won't be cluttered with thousands of primitives, so everything renders quicker. The disadvantage is not possible to edit individual primitives from the Alembic file. Native Houdini lobs work as expected. I can create a new material using the material library lob and assign it to the Alembic procedural. Let's stop here for a second. As you can see, the schemas are elementary building blocks, as I mentioned earlier. It's important to mention that the initial release of this new feature focused on empowering pipeline developers, and flexibility was our primary goal. We're actively looking at providing tools that will allow you to import Arnold native file formats with ease or use Arnold operators. The next feature is deep rendering in Solaris. It is straightforward to set it up. First, let's create a render var, just like with standard EXR files. I'm just going to set it to the RGBA AOV. Then create a render product, connect the render var, and set the output file. The next step is the most important. Change the product type from master to deep. Solaris now knows that this is a deep render product, and it will let Arnold take care of outputting the EXR file instead of relying on Husk. The rest is straightforward. Create the render settings, the USD render raw pull-up, and start your render. Let's look at the contents of the rendered DPXR file. To do this, I will import the lob camera and use the deep to point tool from the Accent QLib library to display some nice and colorful points. Hey,
Okay, so to finish on USD, Arnold USD in Solaris, so I'll show like lots of production features. Those are coming from lots of collaborations. We have with many studios who are migrating to a USD pipeline, through Solaris or through Maya, but with Arnold. And we want to take this opportunity to thank all those studios who give us really valuable feedback from people who are actually doing the switch to USD in production. So I wanted to highlight this particular studio, Megalis, who were the first. Technically, they're not the first to have started using Arnold and USD, but they're the first to release some images on an upcoming production for a Netflix series, animated series called Oni, and it's looking really sweet. And they very kindly tweeted this update where they stated that they were using Arnold with USD in Solaris. So cool. All right. Now, moving on to concluding this webinar, I'm going to continue with a few miscellaneous features of Arnold 7. And first of all, I want to talk about multiple shader outputs. So this is a kind of a deep change for us, and the fact that it's a big version release of 7.0. This is the opportunity for us to change kind of fundamental things in Arnold, and this is one of them. Now, for years, Arnold shaders have been limited to a single output. Now they have the possibility to have several outputs. So you could have, say, a color output or 2 or 20, and a float output. So anything you want. So this is all possible. For now, it's only exposed through OSL, because with OSL you can write such a shader with multiple outputs. So that will work out of the box. And we're thinking of exposing releasing new shaders that take advantage of this feature. And other features, so we've introduced the possibility to apply LUTs to do tone mapping in images. We have also often requested color curves imager to do color correction. We have added the possibility to do SSS sets with random org, and I'll explain. This is this is illustrated by the images on the right, but I'll explain in a few moments what this is about. Also, very often requested the ability to render EXRs in multi-part form. So, if you render EXRs with lots of AOVs, they become very big. There's very big files, and if they're not multi-part, then it takes a long time to load in Nuke and your favorite compositing package. It takes a long time because you have to load all the layers, and it eats a lot of memory also. Multi-party XRs are designed to work around this limitation. So even if it's a big EXR that contains a lot of AOVs, the fact that it's multi-part, that has this special multi-part format, makes your compositing package go directly to the layer you're interested. So it's a lot faster to load, and you're not paying the price of having lots of layers in your EXR. We've also updated Material X and Cryptomatic to the latest versions. So let's discuss a little bit SSS sets with random walk. So SSS sets were available with other SSS methods, but everybody loves random walk because it gives this realistic look for SSS. But unfortunately, it didn't support the SSS set. So what are SSS sets? One problem you have with SSS with different objects that are close to one another, or even interpenetrating, if they have different materials that have SSS, well, the light doesn't go from one object to the other, and thus you have this darkening that you see in here. So you see, if you can see my pointer, the gum has obviously SSS, the teeth have SSS, but the light doesn't go through the teeth to the gum and vice versa. So you have this darkening at the interface between the teeth and the gum. With SSS sets, you can say, okay, teeth and gum are part of the same set, and light can travel from one object to the other. And this is after, and it's quite subtle, but you see the darkening has mostly disappeared, right? So this is before, I think you can see it very clearly in the lower teeth row. So this is before and after. Okay, do it again, before, after. It's quite subtle. You can see it in this object also, how there's more light at the intersection here, instead of this dark, this dark line. Okay, now I finish with some another feature that is really important for us. It's kind of not really exposed, like in a very, it's not really in your face, but it's really a big deal for us. It's the ability to do multiple render sessions, which means that you can render several scenes within the same Arnold process, well, within the same process. And this is a toy example of multiple scenes with various parameters, rendering with different render settings, all rendering within the same process. And sharing happily sharing the CPU resources. Okay, this is useful for example, like an immediate application of this is if you're rendering your main scene and you're updating a shader ball, and that's a different render process, like they can live together. You don't have to stop one render to do the other one. This was a big limitation of Arnold. It required a lot of deep architectural changes in Arnold, but yeah, we're going to leverage this more and more in the future. So that's cool. And lastly, here's a funny feature is the ability to render within a terminal. So yeah, you heard me right. I don't know if you can see, but you can type in a terminal. You can type in a terminal, and it displays in the image in low resolution directly in the terminal. So why did we do this? And you see, it's even interactive. Why would you do this? Well, first of all, because it's fun. That's a good reason. But also, it's interesting when you are logging in a remote server and you want to see, you want to do a test render, and instead of having to set up something complicated, sharing your screen or whatever, just through an SSH connection with a terminal, you can render and see how your scene looks directly. Okay, so finally, what's next? Well, first of all, I'd like to thank you all for your feedback. Thanks for reporting all the bugs or all the good stuff. When you're happy about the results, we're getting lots of those. People are happy about the denoiser in particular, and then the GPU speed. I just want to announce that we have a bug fix release coming soon to address the first batch of feedback that we got. There's lots of bug fixes in there. So yeah, thank you for all the feedback. And we want to release those bug fix releases as early as possible. So yeah, it's coming really soon. And that's it. That's it really. That's the end of the presentation. So we're going to switch to Q&A now, I think, Jennifer.
Yeah, we can start answering the questions.
Okay, so I didn't have a chance to look at the questions. So what do we have?
I believe Adrian had a few he wanted to answer.
Okay.
If you answer directly on the computer, so this will be simpler, right? Okay, so there's a question asking, will be Arnold GPU support connected colors and position for ramp RGB in the future, or is this support not in the roadmap? So yeah, it's something we want to do. So just a bit of context. When ramp RGB is used with constant positions and colors, the output curve of the ramp is baked and fast to evaluate and to render. And when positions are connected to the shader, the curve has to be reconstructed on the fly on every shading point. And this is slightly trickier to do and hasn't been ported yet on GPU. Getting that to work on GPU is, yeah, that's definitely something we want to do. And to give a bit wider context, like Arnold has thousands of smaller features like that. And definitely your feedback is super important to help us prioritize and sometimes remember that which feature is important and what to work on next. So yeah, thanks for bringing that up.
Thank you, Adrien. There's a question about Houdini and IPR. So I think Zero reporting a question from the Discord server. I don't know which Discord server, but I guess yours. So is Autodesk planning to add Arnold's IPR window in Houdini because regular one is clunky? And if there might be some improvement for H2A and interactivity, especially live update on sub level in IPR. Pressing render button on every change can be frustrating. So yes, that's a very common request. We understand your frustration. There has been some improvements, especially I think most of the things that you can do in the shading network, such as connecting, disconnecting, changing parameters. Like this is well supported. Updating the geometry, I can't remember off the top of my head, but there was an improvement recently. But we really need a rehaul. We've been wanting to do this for a long time. It's kind of complicated. It's just the heart of the translation, and so it's definitely something we're looking into. I know we always say this, but like really, and you're not the only one to give us this feedback. So yeah, we know it's a priority for H2A. To be honest, there's lots of our resources on H2A that are taken by Solaris because there's a lot to support. It's the brand new thing. Everybody wants this to work well. In Solaris, the interactivity is pretty good, though. So we that shows that it's really possible. One last thing that I would say about this is that the IPR window, or as we call it, the Arnold render view, that is integrated in Maya and Max is great. We'd like to integrate it in Houdini and other applications we support too, but that doesn't solve the interactivity problem. It's not. It's deeper than just the window. The window is part of it, but it's not a magic bullet, unfortunately. Okay, so bear with us, but yeah, duly noted. Next is from John. Tying to this, is there a possibility of adding a GPU pre-populated cache complete solution that does literally every permutation under the sun, not just the common ones? Something we could run overnight when artists go home. So do you want to answer this?
Yeah, I can answer that. And there was a related question regarding giving users a better status of what is happening there. So just again to give a bit of context what the permutation is, it is something that is not specific to Arnold GPU. Like all the video games are using permutation in the shader, meaning that permutation is a way to enable or disable a feature dynamically and optimize the GPU program for the subset of feature that the scene is actually using, right? And you can have 100 of those permutations, and the complexity is combinatorial, meaning that it's 100 times 100 times 100 permutation. It adds up very, very fast. As every time you add another permutation, for example, you disable lights, you disable curves, you disable volumes. This permutation adds up to all the other permutations. So the complexity explodes. And even with 8, 9, 10 permutations, suddenly you're looking at rendering hundreds of thousands permutation, and it gets really scary really fast. So we try to, in the pre-population, to cover all the most common ones, but even there, it's definitely not perfect. So really, what we're trying to work on, instead of optimizing for the slow path, is optimize everything and reduce the amount of time it actually takes to compile what is used in the scene. That's more our approach, and that's more focus, making sure that the compilation is more and more parallel, that each compilation unit is smaller. We eventually want to get rid of the preparation completely. That would be our goal, because it's not a perfect tool. And definitely giving better feedback to users about what is happening when those compilation phases are happening is super important. And this is an effort we're trying to have in all plugins. The info is actually in the log. If you look at the log, you actually see what is happening, but it needs to be better presented to users for sure. Thanks for the question.
All right, so moving on. So we have a question that is a bit tricky for me because I'm not a K2A specialist. There's been down the road for merging AOVs in K2A. I'm going to defer this because we need an answer from the K2A specialist. We're going to have none here.
So anyway. Fred, I actually talked with Mike, and so he said that is something that he's definitely interested in getting done.
Okay, cool.
No ETA, of course.
Yeah. Next question from Zero. Cinema 4D has Arnold scatter tool. Any plans to bring to other DCCs? Quite difficult to have complete as scenes when we have to use Forest Back in 3ds Max, for example. There are plans. That's all I can disclose. There are plans, not necessarily the plans you're hinting at there, but there are plans to have like procedurally a way to procedurally generate stuff at render time. So scattered, instanced stuff, especially in 3ds Max. Okay, I'll stop there. decals. Quite practical, and recently it was introduced in some engine renders. Do we have
So I can answer like
Yeah.
So it's decals it's very like video game feature, like where you're able to project a texture everywhere else, and it's really just that, like, it's texture projection but generalized on the whole world, so you don't have to rig up shaders or UVs or whatever in everything. It works across shapes, so it's like everything to do that is actually there in the engine. It's because it's particularly big shader override, so it could be implemented or presented at the user level. No plan that I know of to implement that as a first class feature, but it's, yeah, it sounds very, very doable.
So yeah, so it boils down to having a camera projection shader.
Yeah, override on the whole scene.
Yes.
And it's very doable. Like, you could do that with operators and add that on top of the shader with blending or with AOV shaders. So
But it's not going to be very convenient though. But
yeah.
And so the bricks are there. So it's about presenting it in a nice way. Yeah, look at the camera projection shader for sure. That's giving
Camera
you
projection and AOV shaders, which are ways to override
Yeah.
and add stuff on top of all the other shaders. And that's how I would start to implement it for sure.
Okay, thanks for bringing this up. For the Arnold camera, can we have custom bokeh textures? So they're so not out of the box, but there's a shader, like a camera shader that does this. What's the name? It's
Lentil from
Lentil. Yeah, so Zeno Pilgrim. I don't know if you're familiar with Zeno's work, but he has a camera shader, and it's actually a set of tools to do exactly that. And he goes beyond that, where he really has a physical lens model for the camera, so you can achieve very realistic bokeh. Yeah, and it looks cool. So yeah, you should give it a go. Lentil is the name of the camera shader. Oh, I'm sorry. There was a follow-up question on the chromatic aberration filter for imager. Yes, it's one of the images. We have a long list of such images, so that we would love to implement. It's just yeah, this one has been mentioned a few times. Might be the next one. I don't really know. We still have to decide. Arnold on Metal Mac OS, no plans for this. I'm going to give you like the usual answer. Committing to hardware or SDKs is extremely costly. So yeah, obviously there's like it's quite successful. There's new Macs with interesting GPUs and you know, and you have to use metal. I would love to be able to just use optics and NVIDIA hardware like we do, even if it's an external one. That I think a lot of people would be happy with it, but it's not possible because Apple and NVIDIA don't get along, I would say, or haven't found an agreement is a better way to state this. But yeah, we're considering it, but it's not on the roadmap in the near future. Is it possible to join the Arnold Max 2A beta? It is very possible. Reach out if you wanna join. We're looking for beta testers that give us feedback. We have lots of beta testers, but they don't all give feedback, and that are nice and fun to work with. So yeah, if you're such a user, like, you're welcome to join the beta. Oh yeah, so a follow-up from Jonathan on Lentil. yeah, the version 7. So is that I think that's what you're referring to. So having a version of Lentil for Arnold 7. So we are working with Zeno to make this happen. I can't. I don't know when it's going to be ready, but we're actively collaborating with him to just make it happen. This is challenging because of some changes. So we have a question from Etienne. Blender official plugins like RenderMan, like RenderMan did. We're always considering new integrations. There was a Blender plugin for Arnold a while ago that we didn't support. That was a kind of I would say an enthusiast project that was good. We tried to help them, but supporting fully a plugin is a lot of work. Like, we don't just release one version. Like, we have to really support. If you use it in production, we'll support you, and we'll fix the bugs and try to sort you out if you're in production and you're stuck. So it's a commitment. We are considering it with other integrations, but certainly this one is coming very often. Okay, so we're not dismissing it, but I can't commit to anything. All right, I think we're running out of questions. So, and we're at the top of the hour, so maybe it's time to wrap up. Jennifer.
All right. Thank you everyone for joining. If you missed anything in the webinar, don't worry, we'll post it on YouTube shortly. To stay up to date on the latest Arnold news, you can follow us on Twitter at Arnold Renderer, or follow our YouTube channel at Arnold Renderer. And visit our Arnold timeline to see what's new in Arnold. Thank you, everyone.
Thank you.
Bye.